In this video, we're going to learn about inverse functions. We will find inverse functions of lines, rational functions, square root functions, quadratic functions, cubic functions, and more. Watch to the end so you can find out how to verify that the inverse function is correct and to see a problem where we have to use the quadratic formula in order to come up with the inverse function. Don't forget to hit that subscribe button. The inverse function is denoted as f to the negative 1 power. That's the inverse function. It is a function that has the inverse coordinates of the main function f. The inverse function basically undoes what the main function did. So if I have one function and I plug a 5 into it, let's say we get a 2 out. So we have coordinate 5, 2, the x and y value. I take that 2, plug it into the inverse function, I'm going to get back out a 5. So it basically undoes what the main function did. I got plug in 5, I got a 2 out of the main function. I take that 2, plug it back into the inverse function, and I get a 5. So the coordinates in the main function were 5, 2, and the coordinates in the inverse function were 2, 5. It undoes what the main function did. So a function has an inverse function if and only if it is a one-to-one function. A one-to-one function must pass the horizontal test. So in this first graph, if I were to draw horizontal lines, I would only hit the graph in one spot. Okay, so that would be a one-to-one function. If I were to do the same with this one, I would hit it, in two spots as I draw this. So this is not a one-to-one function. So any particular y value should only have one x value associated with it. So what type of functions are typically one-to-one functions? We can see clearly a line is one-to-one. We just saw a cubic, that's typically one-to-one. A square root function looks like that. Exponential be like that. And if you look at a parabola, we just saw that's not one-to-one, but if you were just to look at one half of it, like this right side of it, that alone would be a one-to-one function if you disregard the left side of it. So what are the steps to find the inverse function? All right, so first we're going to change the f of x to y. After that, we're going to switch the x and y values and then solve for y in terms of x, then substitute f negative 1 of x for the y. So basically, change the f of x to y, swap the x and y values. Where we had an x, replace it with a y. Where we had a y, replace it with an x. Then you want to solve your equation for y. And once you have that, change the y to the inverse function notation. All right, so our first function is f of x equals 3x plus 4. This is a linear equation. All right, so my first step was to change the f of x to y. So we got y equals 3x plus 4. My next step there was to switch the x and y's. So I now have x equals 3y plus 4. Now I want to get the y by itself. So I'm going to subtract 4 from both sides. I got x minus 4 equals 3y. And now to get the y by itself, I need to divide everything, both sides, by 3. All right, leaves me y here, and then x minus 4 over 3. Or I can write it as y equals x minus 4 over 3. And your last step is to change the y to the inverse function notation. So then x minus 4 over 3. So that is our inverse function. So let's say I want to define f of 2 in the main function. It's going to be 3 times 2 plus 4, or 6 plus 4, or 10. Now if I take the inverse function of 10, it leaves me with 10 minus 4 divided by 3. 10 minus 4 is 6 divided by 3. 6 divided by 3 is 2. So I plugged in 2 to the main function, got 10. Plugged in 10 to the inverse function, and got 2. So it undid what the main function did. So we had 2, 10, and then 10, 2. All right, so that is one way to check your answer. If you plug in one value into the main function and get your y value, your answer, plug that same result into the inverse function and see if you get the same number you started with when you put in the main function. This next one, we have f of x equals x divided by x minus 2, where x does not equal 2. Now we had to restrict the domain because we don't want division by 0, so x can't equal 2. So again, we start by changing it to y equals x over x minus 2. And then we want to switch the x and y values, so x equals y over y minus 2. Then from here, I want to multiply both sides by y minus 2. Okay, that's going to cancel that out. Gives me y minus 2 times x equals y. Remember, our goal is to get the y by itself, but I have another y on the left side and the right side. So I'm going to multiply out the left side. Y times x is xy. Negative 2 times x is negative 2x. So xy minus 2x equals y. Alright, so I'm going to get the y's to the same side. So I'm going to subtract y here. That leaves me with xy minus y minus 2x equals 0. Now I want to add 2x to both sides to get it on the other side. So give me xy minus y equals 2x. So let me write it over here. Now I'm going to factor a y from the left side, so y parentheses x minus 1, so that's just factoring it. I'm going to divide both sides by x minus 1. So y equals 2x over x minus 1. And we can change that to the inverse function notation. So that gives us 2x over x minus 1. That is the inverse function. And then we got to look at the domain. Again, we don't want to divide by 0, so that's when x is not equal to 1. Because the 1 will cause division by 0. 1 minus 1 will give us 0 on the bottom. So this one we have f of x equals the square root of x minus 2, where x is greater than or equal to 2. Now remember, with the square root, we can't take the square root of a negative number. So it has to be, if I have 2 in there, it'd be 2 minus 2 gives you 0, which is fine. But if I had 1 minus 2 is -1, that can be a negative number, and we're not able to take the square root of a negative number. So it has to be at least 2 for x in order for this to work. So again, I'm going to change f of x to y. So we get y equals the square root of x minus 2. Now I'm going to switch the x and y values. Okay, so now I got the y underneath the square root. Now to get rid of the square root, I need to square both sides. That gives me x squared equals y minus 2. And then to get the y by itself, I'm going to add 2 to both sides. So I get x squared plus 2 equals y. Or if I just write out y on the other side, y equals x squared plus 2. And then I'm going to change that to the inverse function notation. F of -1 of x equals x squared plus 2. And we have no restrictions on the domain here. So there's no division by 0, and there's no square root on this side. Now, since our original function had x greater than or equal to 2, our y has to be greater than or equal to 2 for this case. So we won't be getting a value that's less than 2 coming out of our function, because it wouldn't be a matching one on the original. Alright, so this one has f of x equals x squared plus 4x minus 1. And we're restricting the domain to have x less than or equal to -2. So when we have an x squared, that means it's going to be a parabola. So if we're saying less than -2, we're only looking at the left side over here. Alright, so again, I'm going to change this to y. Y equals x squared plus 4x minus 1. I'm going to switch the x and y values, so x equals y squared plus 4y minus 1. Now I'm going to add 1 to both sides. So that gives me x plus 1 equals y squared plus 4y. When I have this, I want to do completing the square, which is to take the 4 divided by 2 and square it. So 4 divided by 2 is 2. 2 squared is 4. So I'm going to add 4 here. I also need to add 4 to the other side to make it balanced. So now I have x plus 5 equals y squared plus 4y plus 4. So then I can write that x plus 5 equals y plus 2 squared. That was the whole point of completing a square. If I have y times y is y squared, y times 2 is 2y, 2 times y is another 2y to give me the 4y, and 2 times 2 gives me the 4. So that's perfect square of this, multiplying this out using the FOIL method. Now when I have a square, I showed in the other examples, get rid of the square, I want to take the square roots of both sides. So when I do that, I get plus or minus the square root of x plus 5 equals y plus 2. And when I get rid of the 2, so I subtract 2 from both sides. And then I'm just going to write the y on the left-hand side. So we got -2 plus or minus the square root of x plus 5. Now remember, we're dealing with the left-hand side of the parabola. So that's going to be, we're going to throw out the plus square root of 5, square root of x plus 5, just give us y equals -2 minus square root of x plus 5. So that would be the only answer that works. So we don't want the right-hand side values. And we also need to restrict this domain, and we don't want x to equal -5. Or even, so -5 will give us 0, so it can't be less than -5, so actually it needs to be greater than or equal to -5. So this one deals with the cubic, so remember it looks like this. Again, I'm going to write this as y equals x to the third plus 3. Then switch the x and y. Gives me x equals y to the third plus 3. Now I need to solve for the y. So I'm going to subtract 3 from both sides. Gives me x minus 3 equals y to the third power. Now I get the y by itself. When I had to square, I had to take the square root. When I got the third power, I got to take the third root of both sides. So it leaves me with just a y here, and then the third root of x minus 3. And I can write it in inverse function notation. So f to -1 equals the third root of x minus 3. So in this problem we have f of x equals log of x plus 3. Since we can't take a log of a negative number, x has to be greater than or equal to -3. So that's a restriction on our domain. So again, I want to write it as y equals log of x plus 3. Then switch the x and y. X equals log of y plus 3. Now I want to write this in exponential form. Remember, this is log base 10 of y plus 3, so you write it as 10 to the x power equals y plus 3. I want to subtract 3 from both sides. So I get 10 to the x power minus 3 equals y. And then again, we write it as the inverse function notation equals 10 to the x power minus 3. So that's the inverse function. So in this question, we have f of x equals 3 to the x power minus 2. Again, I'm going to change it to y equals 3 to the x power minus 2. And then switch x and y. And then when I get the y term by itself, so I'm going to add 2 to both sides. So x plus 2 equals 3 to the y power. Now I get the y out of the exponent position. I want to take the log of both sides. So log of x plus 2 equals the log of 3 to the y power. Now using the rules of logarithms, this y can come out to the front here. It can be y log of 3. And then just bring down the log of x plus 2. And then I can divide both sides by log of 3. Remember, that's log base 10. So log base 10 of 3. That cancels out logarithm here, leaving me with just y equals log of x plus 2 divided by log of 3. And again, we can't take logarithm of a negative number, so x here has to be greater than or equal to negative 2. So now I want to take time out to show you how you can verify your answer. One way was to plug one number into the main function and get your result, take that result, plug it into the inverse function, see if you get the same number that you started out with. Now another way is to do a composite function of f of negative 1. So if I find a composite of this, I'm going to plug in the f of negative 1 function into the f of x function. So what that does, I'm going to take the 3 times x minus 4 over 3 plus 4. So I basically took the inverse function and plugged it in for x into the main function. Now if I multiply that out, the 3 is going to cancel out, gives me x minus 4 plus 4, which will reduce 2, because negative 4 plus 4 is 0, so equals to x. If you find f of the inverse function, you're always going to get x out. Because if I plug in some value into the inverse function, I'm going to get some number out. If I plug that number into the main function, I'm going to get the number that I started out with. So the combination of these two functions just yields x. What I put in, I'm going to get out. So this is one way to verify your answer, to see if your inverse function is correct. All right, so this is the problem I told you about in the beginning, where I had to use the quadratic formula in order to find the inverse function. So let's take a look at this one. So I'm going to replace f of x with y. So y equals 2x over x squared plus 2. I'm going to switch the x and y values. So x equals 2y over y squared plus 2. And multiply both sides by y squared plus 2. And when I do that, I get x times y squared plus 2. That's going to cancel out the y squared plus 2 over here, equals 2y. And multiply out the left-hand side here, gives me x times x squared plus 2x equals 2y. Now I'm going to move the 2y to the left-hand side by subtracting 2y from both sides. That's going to give me xy squared minus 2y plus 2x equals 0. Now this looks kind of odd. I have xy squared minus 2y plus 2x. So that's not normally, I can't really factor that. So if I look here, you know, if I look at the quadratic, it's ax squared plus bx plus c. And really our y is our x term. So we really have a y squared plus b y plus c. So our a is going to be x, because that's what's in front of the y squared term. So our b is going to be negative 2, that's what's in front of the y term. And our constant value, our c value is going to be 2x. Now I use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac over 2a. And that's what y is equal to. So we said b was negative 2, so negative 2 gives you positive 2 plus or minus b squared, so negative 2 squared minus 4, our a was x, and our c was 2x, divided by 2 times a, which is x here. And if I simplify this, negative 2 squared is 4, and negative 4 times x times 2x gives us minus 8x squared, and at the bottom 2x. So that was our y, or if we can write it in the inverse function notation. So 2 plus or minus square root of 4 minus 8x squared over 2x. So that's going to be our inverse function. So this was a complex one where we had to use the quadratic formula in order to find the inverse function.